Good morning, respected sir, ma'am, and my dear colleagues. Myself, Gaurang. I am from Savarjani College of Engineering and Technology, Surat. My dissertation topic name is data aggregation to extend life of wireless sensor network. Next. This is the outline of today's presentation. First of all, motivation, then introduction, precision allocation method, which I have followed, experimental work, conclusion and references. Motivation. Wireless sensor network is an energy constrained network. Energy is the main, in wireless sensor network, all nodes are operated on battery. So energy is the main crucial part of wireless sensor network. Lifetime of wireless sensor network is defined by the energy of nodes. So energy of node is very crucial part for lifetime of wireless sensor network. I have referred a survey paper. In that I get these three things. These main three things due to which energy consumed. First one is data transmission, second one is signal processing, and third one is a hardware operation. In survey paper they also mentioned that in data transmission most of the energy consumed. So I focus on how I reduce the data transmission. Data aggregation is one method from which one can reduce the data transmission and save the energy. Next. Data aggregation. Data aggregation is a global process of gathering and routing information in network, processing data at intermediate nodes with objective of reducing resource energy of node. In figure we can see this. In figure 1, without data aggregation, all nodes sends to the base station. So here 3 packets we have to send to base station. If we apply data aggregation, then at intermediate state we apply some summation, average, or any function. So that processing function and we send only 4 packets to the base station. This reduces the data transmission. Next. These are the benefits of data aggregation. Data aggregation less number of packet transmit, collision less, also collision retransmission less, and increased throughput and energy consumption is less. This is the method or algorithm which I follow for data aggregation. Precision allocation data aggregation. Precision of data is given by error bound. Suppose the present reading is D, then reading in the range D minus E, D or D plus E are accepted, and outside reasoning is not accepted. This is the precision by definition, and this is the fundamental lines which of my algorithm. Nodes communicate with sync only when new sense reading is reading significantly deviates from last sense reading and out of interval. Then only node sent to the base station. Otherwise, node will not send to the base station, and this way less number of packets to the send to the base station. Same error bound problem. If error bound giving all nodes have same, then which kind of problem face is like this? Two main problems. Data captured by different nodes change at different magnitudes and frequencies. Suppose one node is at a location where due to disturbance temperature is very frequently deviates, then due to disturbance that node will communicate with base station very largely. So energy consumption of that node very fast and lifetime decrease. And second one is the energy consumption of node is not same because of the parameter like distance between node and sink. So if the distance between node and base station is very large, then that node will consume very large energy. This kind of problem solved by the precision partition. Give different error bounds to the all nodes. This way we can save the energy consumption of or balance energy consumption. Constraint for error bound. Total error bound allocated to the nodes cannot be exceeded to the total error bound. Summation all nodes have summation equal to capital E. This is the total network error bound we can say. So, and this must be followed. Otherwise, what happens? One node will due to increasing, and then that node will never communicate with base station. So this is the example that I will mention. There are the 3 steps of algorithm. First one is to find the optimum error bound for a single node in terms of energy consumption. Then after candidate based precision allocation. So after finding error bound, we allocate error bound. Third one is the adaptive precision allocation. After periodically we change the error bound. First one, optimum precision allocation. Here is the graph how U and E exponential graph. U is how frequency of communication between node and sink, means how many times node communicates with base station. E is the error bound of node. this is a relation exponential decreasing. So this is an exponential, but most other way decreasing must be. Let energy cost due to so error bound, we can find the error bound of node based on the residential energy and how many number of times communicate base station by this formula E. Now candidate precision allocation. Allocate the highest error bound to the node that have highest energy consumption rate and lowest error bound to the node which have lowest energy consumption rate. Next. Let three nodes N1, N2, N3. Error bound 1, E1, E2, N3 and total error bound say capital E. Then energy consumption rate R1, R2, R3 is suppose R1 less than R2 less than R3. Then consumption of node 3 is very large, so we have to give most of the large error bound to the that node. So E1 assigned to N1, E2 is this is the basic of precision allocation. This way. Added to precision allocation. Adjustment the error bounds of sensor node periodically, and this adjustment period is adjustment period which way. Interval between two successive adjustment is called adjustment period. Note keep in this adjustment period. Note keep the track of update counts in adjustment period for a given node error bound. So it can count the how many times node communicates with base station. And at the end of adjustment period, node sends update counts how many times communicates with base station and energy consumption rate, which by this equation. These two things are not sent to the base station. And that after receiving that thing, node base station calculate the error bound and based on the first optimum precision allocation, which first step of algorithm I have mentioned, and that then at the end we find that new error bound is less than capital ऐसा होगा और इस send simply add to the node which have a highest energy consumption rate. And these things are periodically after every periodically this thing is happen. Experimental work. For error bound analysis purpose, I have done work in MATLAB and energy result comparison or energy related work I have done in NS2. Most of my work is in NS2. I have been only MATLAB for energy analysis. After each adjustment period, error bounds extra work. After every adjustment period, error bounds of node which have highest and lowest station energy are updated, and delta is the error bound of node which has highest energy consumption. In this I have done instead of changing all nodes error bound, I have changed the error bound which has highest energy and which has lowest energy by using delta. This is a network topology. In that I have taken 25 nodes and base station at the upper right corner. This is a data profile for a single specific one node, and this deviation is between -2 to +2 from previous sensitivity. This is the initial error bound allocation to the old nodes. After that, every adjustment period error bound is changed, and at the end of this I get this error bound with different to the error bound. Highest residual energy node after every adjustment period. After every adjustment period, I have calculated which node has the highest energy and error bound and I have changed that error bound, that node's error bound by using delta, subtract from delta of that error bound. And this delta is also added to the lowest after every adjustment period. I have also find which node has lowest energy and I have added to the that node's error bound. This is the value of delta which I have added to the error bound or decreased to the error bound of highest error lowest energy of node. Number of times node communicate base station. So here is a graph which show nodes and how many times that node communicates with base station. So here we can see that node 22 is communicating base station very largely and other nodes are communicate very less time. And this is the graph of residual energy at the end of simulation. I have simulated the 10,000 times, and we can see that though all nodes communicate with base station very differently, but after then also the energy balance here at the end, the energy is very balanced, or we can say is near to the equal level. Now experimental work in NS2. I have compared result in three cases I have done with same error bound to all nodes with different random error bound. Take random error bound which haven't take any parameter with energy or anything. And third one is error bound with respect to the distance between node and base station. These are the simulation parameters. Network topology, here also I have 25 nodes and one base station, which is the upper right corner. This is the snapshot of simulation. Here, same error bound case, the energy consumption of node is very, the lifetime of, after I have run this simulation 100 seconds, and at the end 700 seconds I see that the first node energy, most of the energy consumption, very less energy, 1.3 joule is there. Initial energy 2 joule I have taken. Random error bound, the energy consumption will reduce and get energy 1.8, sorry 1.5, and energy based on the distance, the energy is 1.84, and we can capture the energy consumption is very balanced of all nodes. Here is the large deviation. And at the end of, I have also mentioned that here we can see 1.32 and 1.62 per. So deviation is very large or not balanced, one can say. This is the balance sometimes, and this is the more balanced due to the distance base. 1.85. All nodes have balanced energy consumption around 1.85 after some deviation. Packet to deliver ratio. By same error bound, all nodes communicate with more data transmission. Random error bound, less number of data transmission, and based on distance range, very less, 450. Then AOD is routing protocol. This ratio is so that routing protocol is also capable for successful data transmission. Conclusion. By precision allocation, the energy consumption of node is very balanced. If we give different error bound and based on distance, we can save loss of energy. Increase lifetime. For planning, and these are the references.